Good morning, LCA. It's so cool to be here on the first day of the first ever online LinuxConf. And you've caught me needing to cough right at the wrong moment. So thank you for coming along. And I'm sure there are many people coming to the Open Hardware MiniConf this year that wouldn't normally come because of the Swagbadge. So a lot of our content today is going to be talking about the Swagbadge, how it was made, what it can do, what you can do with it to customize it to suit yourself. So our first session is Nicola Nye and Gelme, who are going to be talking about an introduction to the Swagbadge. And we're doing a little bit strangely today because we have a few people here in my office and we're just going to be switching around and it's going to be very casual. But if you have questions, please put them into the chat in Venulus. And then once we get towards the end of this session, Nicola and Andy can answer those questions. So thank you very much. And Nicola is going to start off with the introduction to the Swagbadge. So could we please have the slides up? There you go.
Good morning, LCA. So lovely to be here and hanging out with you all. Very excited to show you fabulous Swagbadge. Now, I'm just going to bring those up. Awesome. So, people have come and getting the hang of Swagbadge for the first time ever. And just going to find out how to drive this thing because we're doing technology. How do I do a thing?
Focus on to here.
This one?
And then you should. Perfect.
So the aim of this presentation today is for all those people who were shipped their Swagbadges, who went, this looks really cool, but what even is it? To take you today to the point of, I know what it is and I love it. So, do you have questions? Because I have the answers. We sent out just a casual few hundred packets. We're very excited about it. And we think you're going to be excited about it too. So today, it's not going to be a full-on workshop. It's not, hand-holding you to get it all through. Today is just a familiarization session, taking you from the sort of that getting started moment. You've opened the packet and a whole bunch of little bits of stuff fell out. What did you even sign yourself up for? We're going to be talking about getting you to the point where you can run your inbuilt application. And then we'll have a bit of a look at the sneak peek of the next steps. How do you actually go about updating the firmware? Because let me tell you, we have been burning the midnight oil and we have quite the update for you today. Talking about how you can swap applications on the badge because it's not just stuck running the one. How you can go about building and extending your own applications and also extending the hardware. And there's a number of talks throughout today that'll have a look at what's going on behind the scenes with the badge. But most of all, we'll also be looking at some of the resources so that when you've stopped live streaming and you're left at home staring at the badge wanting to still participate in the joy that is LCA, your badge can bring that to you. So first, some context. Why does this badge even exist? Now, if you need another conference t-shirt or a keep cup or a notebook or a pen, you can order that kind of personalised swag from the Redbubble store. But you, lucky people, have a Swagbadge, and it is the best swag ever. Back in sort of September, October last year, the lovely folks at Linux Australia and LCA contacted the Open Hardware team and said, hi, we've got a bit of money, we'd like you to produce the best swag ever. Are you up for this challenge of shenanigans and mischief? Well, John, Andy and John sat there, put their heads together and said, totally, we can meet your budget. We can ship out a number of 100 badges that will fit inside an envelope to be able to be posted to all the LinuxConf attendees and make this online event a little bit more special. The aim was to be able to have a badge that you could connect to the internet that would make it so that even though we're geographically distributed, electronically, we can be connected. But of course, no awesome swag is going to be any good if it's not fun and also hackable. Now, electronic badges have got quite a history behind them. It's not a new concept. Back in 2006 in Las Vegas, DEF CON 14 was the first electronic badge, and it was just a little board that had some blinky lights because everybody knows electronics is better with blinky lights. Now, a badge contains a tiny computer. In our case, we can even hang it around your neck, and it'll do things. Now, our particular badge is Wi-Fi enabled. It can talk Mqtt, which is a lightweight queuing protocol. It's got screens, it's got buttons, it's got touch sliders. You can use it for interacting with others. You can use it just for doing your own thing. John, one of the people here at the Open Hardware Core team, he's actually even set up his proto badge to control his electronic lights and run it as a dimmer switch. You can even add on some standard add-ons. You can purchase these off Tindy and add them to your badge, power them on your badge, and have other people's hardware added to your badge. So we had a budget, we knew we had to post it, we had to get them built and assembled in time for a pandemically slow postal service over Christmas, and able to be extended with common tooling, and we wanted it to be fun for us so that we could share it with all of you. So what are all the bits on the badge? Let's have a look at the anatomy. So at the top, you've got the lanyard hole that you can put your awesome custom blinky lanyard on. This bit is not electronic at all. There are screens, 2 of them. You can peel off the little sticky screen protector that goes on top of it. That is awesome fun. Underneath the screens are actually buttons, so you can push on those screens and the badge will know what's going on. Some of them are more tactile than others, but do be gentle because, you know, the OLED screens, you don't want to smash them. Make sure when you're pushing them, you're pushing the center of the screen, not towards the edge. Down below, there is a computer. This is the controller, the brains of the whole operation. It's a Lowland Light ESP32. You'll hear more about the specifics of the hardware later on when John and John give you the lowdown. We've got 2 sliders on either side. These act both as buttons at top and bottom, but they're capacitive touch, so the computer can actually detect where your finger is along that slidey thing. It's super cool. You've got fancy logo. And there are 4 points at which you can connect additional hardware things, and they're called simple add-ons. If we turn it over on the back, you can see, once again, fancy logo, very stylish. And there is the very important reset button, so that if you're doing software development on the badge, you can give it a kickstart and it'll restart and bring up your new software. Now do note that there is copper conductive stuff on the back. Don't put the badge onto an electrically charged surface. And the other thing to note is that these sliders, while the graphic is on the front, it actually will detect front and rear. So if you're trying to use the sliders, you might want to hold the badge by the edges. How do you power the badge? You will need a micro USB cable. It goes in the slot on the left. I know people have been talking about a battery that you can power it with. We weren't able to ship this to you, but you can hook it up so that it will run independently. And there is more information on the wiki on the kind of battery it needs, where to get one from, and how to hook it up. But all this delightful hardware doesn't work without the software. So what is part of the stack? So we've got the hardware at the bottom. On top of that, we're running MicroPython, which is developed right here by Damien George, who is now back in Melbourne. Andy Gelme of the hardware team has also built this amazing framework for the badge. And it works not just on this badge, but we've also used it in other hardware applications. And it's called Ico, and it's got heaps of convenience functions. So it will help handle your screen updates. It's got event handlers for all the buttons and switches and dials and gizmos. And you'll hear about all of that coming up next. It's got things to keep your badge online and detect if it falls off and reconnect you. And then obviously we've got applications that run on top of this entire stack. So I've mentioned Mqtt a few times. What even is it? The concept of a queuing-based messaging system has been around for a really long time. Mqtt, though, is a lightweight version that's designed for Internet of Things devices. Now we've set up a dedicated Mqtt server in Australia, so we've got nice fast ping times for a change, and it's being hosted by Andy. It's got some special features on it. Security tooling to make sure that people can't misuse it or accidentally DDoS us. And your badge talks to this server in order to figure out if there is an update for it. And we're going to have an update for you today, and it's super cool. And your badges are all just going to detect this and automatically update. You can control your badge also by sending messages to it from an Mqtt client, and I saw on Twitter that someone's already written a web console, so you can use that to send messages to your badge from his web console. Super cool. We're planning on building a whole bunch of other stuff. So many ideas. Being able to send encrypted messages from one badge to another badge so you can talk to another attendee. But what I'm really looking forward to is seeing what all of you guys are going to get up to. So hopefully while we're not going to be able to do lightning talks, I'm hoping that we'll be able to hang out and have a chat in the Hardware BOF channel, and you can show us what you've been getting up to. Now, if you don't want your badge talking MQTT, you can also disable it. All right, that's enough of the background on what we're building. Time to power it up. So, can be a bit scary if you've never really used hardware before. I know I'm only new to it. Last couple of years, these fine folks of the hardware team have been bringing me up to speed and being very patient while I ask them all the questions. And I've asked them all the questions, so now I can teach you. Now, we're going to give you enough information so that you can comfortably and confidently turn it on. So when your badge first fires up after you've plugged it into the micro USB port, it will have no network. It doesn't know what your Wi-Fi password is, and so it's going to come up and it's going to say, configure me. What you do is then you grab your phone and you have a look at the Wi-Fi networks that are available and you connect to your badge. And your badge stands up a temporary network point and it'll start with Ico. Once your phone is connected to the badge's Wi-Fi, you can go to its web server address that's displayed on the badge's screen. It'll prompt you for your Wi-Fi network and password. Once you've saved that, the badge reboots. So its temporary Wi-Fi point drops off, so your phone will go back to connecting to whatever network it was on. The badge reboots, it then will set up and talk to your network again, and it'll say, I am connected. Awesome. Your badge is connected. I'm sure it'll be fine. Now, the Ico software, that framework that we've got running on here, has got a bunch of assistance functions taking place, and you can see some data that will tend to show up in the title bar. Some of the things that I've mentioned in this slide don't exist in your version yet, but it's coming soon, so I want to talk to you about it so you know what it is when it appears. It'll start up by saying, you will see C, and that means that something's connecting, and so that's it trying to talk to your Wi-Fi network. W means your Wi-Fi is on, M is the MQTT is connected, L means system log messages are available, and soon there's going to be F, which means firmware upgrade is available. Then we get into the actual software that we ship with. So out of the box, the app will notify you soon about upcoming talk sessions. People who've been monitoring the Mqtt server can see the messages that I've been sending through. Soon your badge will tell you about those. So you'll never miss another talk. Isn't that cool? And you'll be able to configure which streams interest you in its configuration file. But that requires that you put a development environment set up for that. Not trivial, but we do have step-by-step instructions in the wiki for major operating systems to do that. But what would it be if it didn't do other stuff as well? So it also ships with a demo of that classic game, Snake. There's, when you're only stuck with a teeny tiny screen, building like an MMO is maybe out of the question. But it does have a choose your own adventure game engine, complete with a choose your own adventure about a cat that wants to learn how to fly, and it has to talk to a dragon to do it. We've shipped every badge with an encryption key so that we'll be able to do securely encrypted messages so nobody can see the messages that you're sending to one another about how much cake you'd like to eat. And obviously it's MQTT capable. Now we don't want you to let out the magic smoke or brick your brand new badge, or electrocute yourself or others, or set fire to things. So there's a few provisos, a couple of quid pro quos. Your badge is electrical. Water and electricity don't mix. Don't bath with your badge or take it to the pool. You'll short it out, and that's bad. So water's no good. This scenario's right out, but I will say don't put it in your mouth either. You'll short it out, and that's bad. Look at this terrifying beast trying to look cool with its ice maker. Don't pin your badge to the fridge. Don't use magnets to pin your badge to the fridge. The badge's conductive, and if it's powered, you'll short it out. And that's bad. Got a messy bench, lots of electrical components on it, and you just put your badge down there while you're messing with it. You might short it out and say it with me, that's bad. So what I'm saying is there is no spoon or any other conductive implement that's safe around a circuit board. So how do you keep your badge safe from shorting out? Well, you can shoot it with a glue gun. What we were aiming to do is put little feet on the corners so that if you put your badge down on something, it's not going to accidentally short out. You could use blue tack, give it some blob feet, or in fact any other kind of feet that come to mind, whether that's rubber washers, bits of Lego, or those little sticky furniture protectors. It doesn't really matter, but having some feet so that it's not going to rest on something accidentally, good idea. But I know you want more. So the badge that we ship with you, it's got opt-in automatic firmware updates. So it will not automatically update unless you push a magic button combination, which is 2 fingers on the lower sliders. It will pull the latest down from GitHub and install it for you. No fancy environment required on your desktop if you don't need it and want it. We can have multiple applications going on, but this is a tech conference. We like hacking, we want hacking, we actively encourage hacking, the good kind anyway. So the software is extensible and we want you to write your own. And the hardware is extensible. And if you'd like some more details about that, check out John and John after the break, and they'll be talking about the add-ons and the hardware that made up the badge. Right now, I'm imagining you guys all at home right now, hacking away on your badge, girls getting out your badges, all of the people. All right, so who put this thing together? These are amazing people, and I mentioned that we started off back in September, October last year. Our lives have been on hold while we've been putting this together. It's the scope and size of a decent Kickstarter, as in fact our projects are every year. But this time we had to deliver before Christmas. Very weird, kind of great. If you're looking for help, these are the key people who'll be able to help you out over the course of the conference. You'll be able to find us in the chat rooms, in the Open Hardware BOF session, which we'll be running at lunchtime, and probably other times we'll be hanging around as well, or come and talk to us on Spectrum. So the link to a lot of this is in the piece of paper that came with your swag badge. So if you need more help, where do you go? There's the wiki, openhardwareconf.org, I think.
Yes.
Hey, it was. Yes, I've even got the URL there. I could have just read it off the screen. So there's this getting started guide in there. There's information about the software it ships with and how to write your own. There's information about the hardware it ships with and where to write your own. Sorry, people who aren't in Australia and want one of these and want a DAG badge, there is information on the components to build your own DAG badge, but the information about hooking it up is still a little bit lightweight. We've been so furiously focused on LCA that we haven't quite caught up with our DAG badge hopes and dreams, but they're coming soon. And it being a wiki, if you get to it ahead of us, we'd love to have your contribution. So we've got Spectrum set up that's attached to our GitHub. We are featured in Diode issue 41. Super cool. So you can check that out. They're a sponsor of the conference. And you can catch me on Twitter at Swagbadge2021 for all your delightful meme needs. That's it from me. So now we're going to follow up with Andy, and he's going to come in and tell you more about the Ico Framework and the ways in which you can use it to help build your own applications.
Sure, thanks.
I don't know how you're going to...
Yep, jump on there.
Well done.
So yeah, you jump on there, and then which at the moment it's only the slides. Hey everyone, we're just doing a speaker changeover right now. So you just want the terminal. Do you have any slides in here or just the terminal? Yeah, just switch to the terminal.
Got it? Yep.
Got it. Good to go. And overhead camera?
Yep.
That's it.
Okay, well, good morning. So I'm using all John's gear, which is lots of monitors and keyboards and things, so it's all unfamiliar, so hopefully this all works out okay. So this morning I'd just like to introduce you to the firmware. This is the software that's running on the ESP32 microcontroller on top of MicroPython. We specifically chose MicroPython because we're hoping to, I guess, reach the largest audience possible, so hopefully everyone attending LCA feels brave enough to jump in and play a bit of Python. And I'm happy to give you a bit of a tour of the code. So rather than using slides, I'll be basically taking through source code and also looking at the console log on the Swagbadge. So what I'm hoping to cover is to how we connect to the ESP32 and work with the MicroPython REPL, which is just the interpreter command and evaluation. Check out some of the low-level functions, how we interact with the hardware peripherals, the pins and the touch sliders, the OLED screens, and then a tour of the high-level framework, and then just quickly chat about the applications. So our project goals were twofold, at least from the firmware perspective. The first was when the hardware shipped, we knew we were mostly going to be focused on developing the hardware, and the firmware would come second. We did have to ship with something that could connect to your Wi-Fi and then upgrade itself, because we knew we were going to have about another sort of 4 weeks to develop code after we'd ship the hardware. And the other goal was once we got the badge to LCA, that we're going to have to I guess address, I think, roughly 3 different types of audience. There'd be those people who are new to microcontrollers, so maybe they're familiar with Python and they probably maybe just use the framework to have a go at creating an application. Second type of audience would be the people who are experienced with hardware, so they probably want to get right into it. And if Mark will be talking a little bit later today, and maybe we'll be able to show you some of the crazy hacks he's done. He's basically took out his drilling, he's drilled into his Swagbadge, he's added more screens, he's really gone for it. And the third audience person, someone who's probably interested in having a badge, but not necessarily programming it. And so choosing Mqtt means that you can send messages to and from the badge without having to do any programming and sort of interact with the hardware that way. So so we didn't want to give you something that's complete. Over the years, the mini-conf has always been about assembly. So unfortunately, this year we had to fully assemble it for you. So and that was a lot of work. That was 300 badges to make. We normally provide the parts to make 50 kits, so it was a huge assembly job. But we still want it to be like Lego, where you take it out of the box and you have to build some stuff up yourself, and so it'll be like that from the firmware perspective. Right. So let's see. So MicroPython on an ESP32 is pretty much full Python 3, roughly version 3.4. So what's different is mostly the modules. You're not going to be doing large, I guess, database web applications in this. What you're going to be doing is using modules that interact with the hardware, the screens and the pins. So that's going to be, I guess, the major difference if you're familiar with Python is the choice of modules that you use. But some of the modules like OS and sys, there's cut down versions of that you might be quite familiar with. Okay, so let's have a look at the machine. So I'll just bring up the terminal now. So what I've got on the left here is just the file system. John, have you got this in Dvorak mode?
Oh, maybe.
John does not use US or English layout. He uses Dvorak, so I've got no idea how to use it.
Fixed.
There we go. I can type again. Fantastic. So if on this is just a clone of the GitHub repository, and probably the three main areas to look at is under applications. We've got some example applications there. The main one we'll be looking at is applications Swagbadge, and also applications schedulers. The scheduler is the application that Nicola wrote that knows how to listen to MQTT messages around the schedule and display those on the screen. So that's in the applications area. The other directory is configuration, and for each of the modules in the framework, there's a configuration file. So there's a file there for like configuration MQTT if you want to know how to configure MQTT. And the other area is the library area. So under library, that's library Ico. That's all the framework elements. And so there's code there for dealing with buttons and the MQTT, the networking, the OLEDs, doing upgrades. There's even a web server and a web client. So that's all there. So that's the three main areas. We'll do a tour on. And the other thing I've got on the right hand side is that's actually hang on, just joins machines around. Is this is the tool for interacting with the device. So I'm just holding down these two buttons that mean the framework doesn't run, so it should boot up a bit faster. Okay, cool. So this tool, which is called npf shell, which you can just do a pip install npf shell to get it, allows you to have a bunch of commands to interact with the device. So you can go a bit like the old school FTP servers, where you can basically go LLS for looking at your local file system, or you can go LS for looking at the microcontroller file system. So so you've got LS, you can CD into directories like sorry, there's no file completion. So CD into applications and do an LS there. So you basically can look at the file system on the ESP32, and you can also put files there. So if I wanted to make a change, oops, just bring it anyway. Thanks, John. So say I wanted to make a change, I could edit a file on the here. So basically, I could edit main, and I know let's put a change in here. So I'm going to put a print statement in. Print hello LCA 2021. Oops, John's editor's doing completion for me. I can then go and put main onto the device, and now when I go into the REPL, if I now reboot the device, just see it just said hello LCA 21. So I just edited on the fly. So that's pretty much the way you develop on the machine. You edit the file on the host, use npf shell to do a put, and there you go. Now we're just watching the rest of the machine come up. So we can see it's bringing up Wi-Fi, connecting to Tron's router. It's now connected to MQTT, and we can now talk to that device. So we've got a standard MicroPython REPL, so we can add numbers and print hello. So it's really quite a lot of fun to be able to interact directly with a microcontroller. If only I could type whilst talking. And you can also get help. So that's help is pretty useful because that shows us how to use all the various Python commands. So especially if you do something like we go import machine, which is a module for interacting with the hardware, you can just go help machine and find out all the things you can do with the machine. So for example, we can create a GPIO pin. We can go like pin equals pin number 12. Oops, oh sorry. That should be machine.pin, and then we can do something like pin.value and read the value of that hardware pin. Currently it's 0. So I just wanted to give you a quick sense of what it's like to interact with the device. Now, once we do that, now we know how to interact with the device. Now it's a matter of having put some of the functions. So, for example, if I want to look at the touch pin, I can basically go pin equals touch pin. I think 12 is the touchpad. like that. Oops, sorry, I forgot to actually go to put machine in front of all these. Oh, sorry, touchpad. Doing this all from memory. Right, and we can go pin.read, and it's currently 310. Now, if I touch that touchpad, I think this is the right one. Yeah, see, if I take my finger away, it's about 300. If I put my finger on it, it's 120. So that shows that we're touching it. And if you look at the slider, if I move my finger along the slider, you can see how the value is increasing as my finger moves. So this is a really cool thing about MicroPython and microcontrollers. You can just interactively play to get a feel for how you want to write your code. So one of the things I mentioned is that MicroPython is sitting on top of FreeRTOS, which is a fairly sophisticated operating system for microcontrollers. So which is also open source. So it's actually quite a lot of interesting things going on here. Okay, so now a bit of a tour of the code. So the starting point is when the machine boots, it effectively runs a piece of code called main.py, and often you would just start by putting your application directly into this file called main.py. So you might want to read a button, write to the screen, and maybe send a message. You can do all that in main.py. But instead, what we've done for this framework is we've basically put all the initialization of the system in here. So you can see we're on line 25. We're importing the event mechanism. So basically, it gives us timers, event timers, things like that. Networking for Wi-Fi, Mqtt, the system UI that allows us to do firmware upgrades and so on. And we have LEDs, if you like, RGB LED streams, as Mark Mellon does. We can, if we've got OLED screens, we enable those. We've got the upgrade process, and then finally, this most interesting bit for writing applications is we look and see if there's an application defined. We run that, and then we run the event loop. So that's what our framework's put into this main loop. And so one of the things we want to do is run application. So if you look in our configuration for main, you'll see that line 8. That's where we changed the application. So we said we want to run an application which is Nicola's scheduler, and that's there. And you can see we've got a whole bunch of other development applications as well. So that's where we use configuration to make changes in the framework. So that's main. So that's the main code, and that's pretty much calling all these lower level functions in the framework. So to have a look at those. Like if we first one that's interesting to look at is networking. So just down to library, down to Aiko. If we look at networking, we'll see that the very bottom has an initialize method. This initialize method starts off a background thread to keep Wi-Fi going, and the other thing we do is we also start Mqtt. So that's what network is mostly looking after for you. And if we just look at what the loop is doing, that loop is basically going to change this little enunciator, which basically says, hey, what's the state of Wi-Fi? We try and make a connection to Wi-Fi, and then if while Wi-Fi is connected, that's fine. And then if we need to connect and we start again. So this is basically a loop that will continue this loop around, trying to connect to the Wi-Fi's, keep it alive, and then disconnect if it needs to. And then after a period of time, if we can't connect to Wi-Fi, what it does is actually down the bottom here, we'll start a Wi-Fi configuration process, which what happens is when you first get your badge home, it doesn't know your Wi-Fi credentials. It tries to connect, can't do it. So then it brings up a web server which allows you to then configure your Wi-Fi and SSID password through using your phone to talk to the badge, and then after that it'll have the credentials. So I realize I'm running through this a bit quickly, just wanted to give you a bit of a flavour. So that's networking. So some of the other main things we've got is buttons. So let's put buttons. So at the top of every source file, there's some examples. So if you want to look after buttons, what you do is you'll create a handler. So this handle will basically be given the button number and the state of the button, true or false, and you then just add that button handler. And we support both regular buttons, which are the buttons under your screen. These are just two little GPIO buttons, and also we support the touch sliders. So let's just try this. So we can basically just see if I can cut and see if cut and paste works. Maybe if I get lucky. I haven't used John's machine before, so I don't know how lucky I'll get with this. So no, I might just have to type this in. That's going to be a bit slow. So define handler, number, state. Give me a sec. John, is any reason why cut and paste is not working easily?
Yeah, it doesn't like working out of Vim for some reason.
Oh, really? Oh, that's right. Okay. I'll see if I can. I'll just go.
I think if you cut the file, you should then be able to copy.
Oh, okay. Let's do it that way. More button. Sorry, just figuring this out on the fly. Oh, that's much better. Okay, great. So just define the handler. We're going to print the button.
It's about 10 minutes now.
Yeah, thanks. And now we're just going to add that button handler. Now, whenever we press the screen, there we go. That's I've pressed that left screen, released the screen, pressed the right screen, and released it. So that's the sort of outcome we're trying to get with the framework. Is just, you can just add a few lines of code, and it just works. We can also do the same thing for the touch slider. So that's basically going to enable all those buttons on the touch slider. So now if I press press and release that bottom button there. And where this gets a little more complicated is we can do things like also define a multiple button handler as well. So it's like for pressing and holding two buttons. So if we just define that. Oops, what went wrong there? Cut and paste error. Multi-button. And what I'm going to do here is actually, if we press the top two buttons and hold the top two buttons, we should get a handler thing called. So press and hold these top two buttons for 3 seconds. That should call the, there we go, multi-button handler on 1528. So that's how we can do buttons. Similarly, there's a whole lot of functions for the OLED. So what we can do here is, actually there's probably not documentation there. What we can simply do there is things like we can go OLED, ico.oled.oleds clear, and if I hit that, that should clear the screen. We can do things like do some text, I think. So we go text. I should just be able to go hello. That should just scroll up from the bottom. That work? 4 parameters. Oh, sorry. The text scroll. Let's text. Oh, let's log. That was the one I was looking for. Let's log. Sorry. And you can see this message is coming up from the bottom, and that's scrolling. And that also, I'll do a long line, say long line, and it's basically writing that across both screens. So that's the OLEDs. There's also a web server if you want to do web serving. So that's a little web server that we provide for so from the phone you can configure the device. So does all the URL decoding. That's for doing configuring Wi-Fi. And there's a web client, so it just allows us to you can use that to basically just do a get on a URL, and that'll load that down as a file. So that's also available. And where we mostly use that for is in the upgrade process. So how that works is there's we listen to an MQTT topic, which then tells us the web server to go to then bring down a manifest, which then brings down all the files. So let's see if we can make that work. So let's see. So what else is worth showing? So just show, I've only got a few minutes left. So to show us how it all comes together, let's have a look at an application. Sorry. So you go into applications. So if we look at the Swagbadge application, what you'll do is you'll fill in an initialize method, and in the initialize method is where you put all your handlers. So you can see I've got a handler called the Swagbadge handler, which is going to get called every 100 millisecond, every 1,000 milliseconds, and that Swagbadge handler is going to has a timer, and every time that timer increments, it's getting the time, and it's then writing that to the screen. So it writes that to the screen. It fills the a rectangle that blank has an error on the screen, writes the text, and does a show. So to show you how to make that run, what we do is we'll edit configuration main. We'll stop running Nicola's application and now run Swagbadge. We'll put that configuration file onto configuration /main.py. Oh, can't spell. Configuration -main.py. Now rebel. Now I'm now going to reboot the machine. And instead of running Nicola's scheduling, it's now you can see it's running a little timer there. So in a few hours we're going to release a new version of the firmware which provides all this functionality I've just shown today. And so how that works is we'll make an announcement saying the firmware is released. You'll be able to go through that process Nicola showed you where you can press the, or say your firmware, you can press the bottom buttons, and then you'll get this firmware. Now this firmware is a bit different in what happens when you press the bottom two buttons. Rather than upgrading the firmware, it actually takes you to like a little system user interface where we can do things like we can look at the console log. We can also select firmware upgrade, and then you can, if there's new firmware, you can then upgrade it. So that's this is new functionality we'll be documenting soon. So I think that's about all I have time to cover. So we're going to do some questions, John. Yeah. So that was a lot to try and cover very quickly. So hopefully that made sense.
All right, I'll just switch the camera back. And yeah, that's fine. Switch back to here. Okay, so we're back in the room. Now, the most important question that was asked was Adam. He wanted to say hello to Astra.
Oh, okay. Come here, little girl. Yeah, she's been very. Yes, this has been our mascot through the whole project. So once we were allowed to travel more than 5 kilometres, I was down here quite often down at John's place. We're working hard, distributing the hardware out to the team. There's a lot of hardware work, and so every time Astra would come down and play with John's dog Bonnie. So she's.
Yeah. So there were a couple of other questions.
Yes,
Spidey asked whether the software update in the stock version, so version 4, works the same way with 2 fingers on the lower sliders. And Andy partly answered that right towards the end of the talk. So it does the update, but the new version of the firmware gives you more functionality with the 2-finger connection at the bottom. It gives you a menu where you can select from multiple things to do, not just do the update.
Yeah. So we're calling those system features. So in the framework, libico, there's a file called system_UI, and that's actually probably a pretty good file to look at because that's that uses all the library calls for doing handling a multi-finger button to get into the UI, a slider to basically scroll through the menu, so it displays the menu, highlights the selected one. There's a button to then select what you want to do. And yeah, so it's actually system_UI is probably the best place to look for examples of how to work.
Okay, and one final thing, so we're pretty much at the end of our time, but what I'm going to do is drop a link in the chat to Spectrum. This is an online chat system that has been set up specifically for support for the badge. So if you have technical questions, problems connecting to it or anything like that, go along to Spectrum and you can put questions there. So there'll be people there to help answer whatever comes up.
Yeah, so for the next 3 days, we'll try and hang out on all the channels. We'll hang out on the conference, teleconferencing. What's the name of the software again?
Venulus.
Oh, Venulus, yeah. So we'll hang out in Venulus, and so there's the hardware buff. So you'll be in there all the time. So if you want to chat, do a video chat to solve problems, so happy to do that, or just whatever. There's Spectrum, as John said. Is there anywhere else we're hanging out?
That's the main place.
Okay.
There is also a BOF area in Venulus. You'll notice on the left-hand menu there is an Open Hardware Miniconf BOF, and that is a text and audio and video channel. So over the course of the weekend, we're probably going to spend a fair bit of time in there as well. Yeah.
So the project doesn't end today. This is really the beginning. It's sort of the very start. I was going to say something like ground zero, but maybe that's not the best best way to describe our project. That feels a bit final. No, this is the beginning. So we possibility that maybe there'll be another badge project in the future, and this firmware will be the basis for that. So if anytime we put into it over the next few days, hopefully will be the beginning of a long-term project.
Yeah, there's plenty more to come. So we are wrapping up this session now. There is going to be a short break, and then our next speaker will be on in about 10 minutes, which is Mark Merlin. He's going to be talking about his usual favourite topic, LEDs. So thanks for coming along, and we'll see you all again in a few minutes. Oh, Nicola is waving goodbye.
See you soon.
Bye.